Today, we're going to be talking about area and perimeter of complex figures. So, sometimes you might be given a figure that we just don't have a mathematical formula for, like the one that we have here, to find the area or the perimeter for. But we can break them up into smaller shapes that we do know how to find. So here we have a problem. Sandra owns a working sheep ranch. She raises a type of sheep called sulfur sheep for their fine wool. The ranch is shown in the picture. And we're being asked what is the total area of the ranch. So everything in here, all of this area, we want to find the total area of all of that. But the thing is, we don't have a formula for this kind of shape. So we have to break this up into smaller shapes. Well, there's multiple ways we can break up the shape. You can either draw a vertical line here and break this up into two rectangles, or you can do it by drawing a horizontal line here and breaking it up this way. I'm going to go with this way. You can choose either way. Both methods work. So I'm going to call this top one here shape number 1 and this bottom one shape number 2. So to find the area of shape number 1, right? Well, this is just a rectangle. The area of a rectangle is just length times width. And we can see that this rectangle is 2 by 3. So the area of this is just 2 times 3, which is 6, you know, kilometers squared. Let's not forget our units. And the area of the second shape here, well, this is a 2 by 2 square. So this is a square because all of its sides are the same. So it is length times width, but both the length and the width are the same. This is actually a square, so on your formula sheet you might see it as side squared. And this is the same thing as 2 times 2, right? We're 2 squared, and that gives us 4 kilometers squared. Okay. The last step, right? So the top area is 6, the bottom area is 4. So the last thing we're going to do is just add them up to get our total area. 6 plus 4 is 10. So our final answer is 10 kilometer squared. Okay, now let's break it up the other way. Let's break it up by drawing a vertical line here. Okay, I'm going to call the smaller one shape number 1 and the bigger one shape number 2. Now, for area of shape number 1, right? It's length times width, but we're missing this length here. So this length, we don't know what that is. Okay, we only have one of the dimensions. We have 2 kilometers here. Maybe we can figure out this length. Well, we know that the whole thing up top here is 3 kilometers. And we know that this portion here, this is 2 kilometers. So that means over here, this portion must be 2 kilometers as well. Well, up here, if the whole thing is 3 kilometers and this portion on the right is 2 kilometers, that must mean this must be 1 kilometer here, the remaining dimension. So now we have our dimensions and we can figure out that this is 2 times 1 and that gives us 2 kilometers squared. So that's for area of shape number 1. Now, area of shape number 2, again, it's length times width. Okay? And we have one of the dimensions here, we have 2, but we don't know what this dimension on the right hand side is. maybe we can figure it out. Well, I know that here, this portion is 2. This is 2 kilometers, right? This is 2. The opposite side must be 2. So that means this first portion here, this first portion here is 2 kilometers as well. Okay? And then here we have 2 kilometers here, this portion here. That means on the opposite side here, this must be 2 kilometers as well. And if you add both of these lengths up, right? So this first half is 2 kilometers. The second half here is 2 kilometers. So if you add them all up, should be 4 kilometers in total. So now we have this the second rectangle on the right hand side here, and it is 2 by 4 kilometers. So we have 2 times 4, that gives us 8 kilometers squared. And the last thing we're going to do is we're going to add them all up. Okay, so the first shape has 2 kilometers squared and the second one is 8. If you add them up, 2 plus 8, that gives us 10 kilometers squared. So we got the same answer. Here's another problem. This time we have Reggie wants to paint a cardboard puppet theater he made for a class project. The paint will cover the entire front of the theater except for the hole he cut out for the stage. How many square feet of the puppet theater will Reggie paint? Well, let's see. Well, let's first start with the theater, the entire theater, right? The area of the entire theater is just 5 by 6. So it's 5 times 6. Sorry, so this is length times width. So we have 5 times 6. That gives us 30 feet squared. But there's a hole for the stage. And Reggie is not going to paint that. So what are we going to do with it? We're going to subtract it. We're going to find the area of the stage and we're going to take it away because Reggie's not going to paint that. Well, the area, so this is area of the theater. Should make that clear. The entire theater. Area of the stage, again, that is length times width, and that is 2 times 3, which is 6 feet squared. Right? And the last thing we're going to do is we're going to take the area of the theater and we're going to take it away. Subtract it from the area with the area of the stage. So we have 30 minus 6, and that gives us 24 feet squared, right? Because remember, Reggie is only painting the theater part, not the hole for the stage. So we have to take that away from the area of the theater. We have to find the area of the entire theater and then find the area of the stage, and then we just subtract the area of the stage from the area of the theater.